Hello everybody, thank you for watching. This is our 5.2 Expanded Lewis Structures video. So in this video, we're going to learn how to draw expanded Lewis structures. The first thing we want to talk about is what is an expanded Lewis structure or an expanded octet. Right? So it is possible for the central atom to break the octet rule and ultimately have more than 8 electrons around it, therefore becoming expanded. So I'm going to show you a couple examples about expanded octets. Usually the elements that are halogens and sulfur, they tend to have more than 8 valence electrons around them because they tend to break the octet rule. So if we take a look at this example, IBr3, we know we have an iodine that has 7 valence electrons around it. Each bromine that is symmetrically placed around the iodine also has 7 valence electrons. So we want to take a look at these electrons and see which ones are going to share and ultimately form bonding pairs. These bonding pairs that are here are sharing these electrons. Therefore, you can replace them with dashes, right? This ultimate central atom, you can see, has 4 electrons around it. We want to rearrange the picture to show the different pairs of electrons that are around the central atom, and we can see that iodine has more than 8 electrons around it. Therefore, it is an expanded octet. Usually, the central atom is where the expanded octet occurs. So iodine has 2, 4, 6, 8, 10 electrons around it, therefore breaking the octet rule and having more than 8 electrons. Another example is I3 with a -1 charge. So whenever we have a -1 charge, we know that we have more electrons than protons. So in this example, we're going to first draw out the Lewis structure for I3 and then talk about this -1 charge and what it means. So we know iodine has 7 valence electrons around it. And in this example, we have 3 iodines. So we want to rearrange these electrons and show where they're going to share their electrons. So you can see that there is a bonding pair here and there's a single bonding pair here. What we can do is we can move some electrons around and then focus on the charge. Because the charge is -1, we want to add 1 electron to represent that charge. So what I'm going to do is I'm going to add 1 electron right over here. Therefore, this iodine has more electrons and has 1 more than it actually needs. We can replace the bonding pairs with our dashes and rearrange electrons to show pairs. In this example, iodine is also an expanded octet and it also has 1 more electron than it needs. So if you take a look here, we have 2, 4, 6, 8, 10 electrons around this central atom. Each of these atoms, they already have an octet. They don't break the octet rule. Only the central atom does. This iodine has 2, 4, 6, 8, and this iodine has 2, 4, 6, 8. So what I want you to do now is please pause the video and try these 4 examples on your own. This concludes our video. If you want help with these practice problems, please come see me and we can go over some of them individually. Thank you.